All right, so let's continue with the first topic that we're on, which is, again, number theory and computation. What we're going to require now is to compute powers. Compute powers. And the objective for today, which comes from the syllabus, is to compute powers of real numbers of the form x to the power of a, where a is a member of the set of Q. And remember, the set of Q is the rational numbers. Now, before we start anything, the first thing we want to talk about is exponentiation. Exponentiation, right? Exponentiation is simply the process of computing powers of real numbers that are in the form of x to the power of e. So the process of computing powers of real numbers of the form, and I'm just going to write the form right here, of the form x to the power of a is called exponentiation. Right? In exponentiation, all we're going to do is we're going to take x, which is the base, oopsie, black, and then put this right here. So in exponentiation, what we're going to do is we're going to take x, which is the base, and multiply it by a times. Right? So we're going to take x, which is the base, and we're going to multiply it by itself a times, which is the exponent. All right? So let me just write that down here in a different color. This means multiplying the base by itself x times. Sorry. Multiplying the base x by itself e times. Right? That makes more sense than what I was going to write. So we're going to be multiplying the base x by itself a times. That's what exponentiation is. Now, your exponents, which is a, can be of any form. It can be in the form of a fraction or a decimal. But when it is that you have it in the form of a fraction, it would represent both a power and a root. And what do I mean by that? So, I mean, if you have something like, let's say, for example, you have x to the half power. X to the half power means x square rooted, right? So the square root of x is x to the half power. Now let's say, for instance, we have x to the 1/3 power. It means the cube root of x. Now later on, we're going to learn a little bit more about indices and the indices laws and how you would tend to deal with these things. But just know right now how to do an exponentiation, which is simply taking a base x and multiplying it by itself a times. Now there are a few common ones that you already know how to do, which is, for example, the squares. You know how to do squares, and squares is just simply a number that is multiplied by itself twice, right? Well, I should really say a number that is multiplied by itself, right? So the square number x squared means x times x. And if I want to give an example being, let's say, 3 squared would be 3 times 3, and that just simply is 9. Right? That's a square. Now, the other version of that is the square root. And the square root of a number is usually written as root x. So the square root of a number x is written as root x. Right? That's what the square root of a number means. And it just simply think of it as a number which, when multiplied by itself, would tend to give you the x. That's how I would usually think about it. A number that, when multiplied by itself, would give you x. So we have, for example, square root of 9. And square root of 9 is going to be equal to either a plus or a minus 3. Because 3 times 3 would give me 9. And negative 3 times negative 3 would also give me 9. Right? So that's why when I think of a square root, I'm thinking of two numbers that, when multiplied by itself, I'm thinking of a number that, when multiplied by itself, would give me that x value. So in this case, x is 9, and the square root of 9 means that I'm thinking of a number that, when multiplied by itself, would give me 9. So 3, when multiplied by itself, would give me 9. So that makes the square root of 9 plus 3 or minus 3. And the other common one that we're going to have is cubes. So cubes. And you can think of cubes, so the cube of a number x is written as x to the third power, right? And all it means, it's going to multiply by itself twice. So for example, if I have 2 to the third power, it simply means 2 multiplied by 2 multiplied by 2. And 2 by 2 is 4, by 2 is 8, so the answer is 8. Next, after this, the alternative to this is the cube root. So let me just go on a new page. Cube root. Right? The cube root of a number x is written as follows. So the cube root of a number x is written as same look as the square root, but you put a 3 over here. Right? Or the other way that we can represent the cube root is by x to the 1/3 power. Right? Now, I didn't specifically state it before because I already showed it. Right? I didn't state it originally before because I already showed it. Look here. X to the half power means square root of x. X to the 1/3 power means cube root of x. Right? I didn't state it previously, but this one I'm stating it on. And you would think of it as the number that, when multiplied by itself twice, give x. Right? So let me give you an example of that. Now, we did 8 just now, so let's go back. 8 cube root. And we're thinking of a number that, when multiplied by itself twice, is going to give me this 8. So if I take 2 and I multiply by it twice, then I would get 8. So that means the cube root of 8, and I can just put this inside a cube root symbol. The cube root of 8 is just simply going to be 2. In other words, what number can appear 3 times to give me 8? Right? So 2 by itself twice, and it will give me 8. You can try a couple problems. So here's a couple problems that you can try. And you can pause the video and do the problems. I will do the solution right away after. All right, so 2 to the 5 to the second power, 25 to the half power, 3 to the 4 cube, and then the fourth one is 64 to the 1/3 power. All right, so let's start with 5 squared. So 5 squared is equal to 5 times 5, which is 25. Then the next one, 25 to the half power, it's going to mean the square root of 25. That means I would be able to put two numbers in these boxes here that can multiply and give me 25. I know that if I take 5 and I multiply it by itself, I would be able to get 25. So the square root of 25 is 5. All right. Let's go to the third one. Now, you don't have to do all of this. I'm just simply showing you a way to think about it. But you can go straight from here to your answer at the end here. All right. Then we have number 3, which was 4 to the 3rd power. And 4 to the 3rd power means 4 multiplied by 4 multiplied by 4, which is going to be 4 times 4 is 16, times 4 is 40, 24, 40 plus 24, which is 64. So we get 64. And then the fourth one is going to be 64 to the 1/3 power is going to be equal to a number that can multiply by itself and fill these 3 little boxes, cube root, and that answer is 4. So I'm just going to write it in here, 4, 4, 4. Cube root of 4 is, cube root of 64 is 4. All right, nothing difficult, nothing challenging, just following simple patterns to solve this.